An FMEA in principle can be performed at any level. It can be performed at a vehicle functional level, it can be performed at a system level, it can be performed at a hardware or a software level, or even at the production side. When FMEAs are performed at different levels, the concept of a hierarchical FMEA is used to link the different FMEAs together. In a hierarchical FMEA, you have failure modes of a lower level FMEA, which are linked to causes of failure modes in a higher level FMEA. But the advantage of this is to make sure that all causes are covered by effects at another level. So this ensures complete traceability between higher level and lower level elements. One such way of implementing this is using a three-level hierarchical FMEA, wherein you have a vehicle function FMEA at the highest level, then you have a system FMEA, and then you have a hardware or software FMEA. At the vehicle level, you do your FMEA for vehicle functions, which includes identification of failure modes, effects, their causes, and eventually measures to mitigate them as well. At the system FMEA, one would do the same thing. Again, identify failure modes of system level components, and when effects are identified, they're linked to causes at the vehicle function level FMEA, so one level higher. Similarly, hardware software FMEA, one identifies failure modes of hardware software components, and the effects of these failures are linked to causes at a system level. So you can see there's a complete traceability between causes and effects. And when we see that one of the causes is not linked to an effect, it could potentially signify a gap that needs to be addressed. Here's an example for cruise control. Um, Cruise control is essentially used in cars to maintain constant speed with minimal driver intervention. At a vehicle level, you can have a failure mode, which is cruise control target speed is very high. The effect of this is unintended vehicle acceleration. Driver sets 70 and vehicle drives at 90. The cause of this is incorrect vehicle speed determination. Now, when you go to a system FMEA and you identify system components, and one of the system components would be wheel speed sensors, which is used to estimate vehicle speed. So one of the failures would be incorrect wheel speed determination, and the effect of incorrect wheel speed determination would be incorrect vehicle speed determination. So this linkage between effect and cause is very important to say this effect uh, covers this cause. Similarly, at the system level, you would identify what one of the causes are. Here, one of the causes is because the system becomes unresponsive. And then when you go at the software level and you're doing a software FMEA on one of the software units, for example, it could be regarding the wheel speed estimation module. Frozen software execution is one of the failure modes, and the effect is that the system becomes unresponsive. A cause here could be a program stuck in a loop. Eventually, you would determine safety mechanisms or measures for each of these. And in this case, the safety measure could be to have a program flow monitor which checks if the code is executed within a certain amount of time. The advantage of this hierarchical FMEA is that you see every cause has to be linked to an effect. And when we see that a cause is not linked to an effect, which in this case has to be linked to a hardware FMEA, we know that there is a gap in design. On the other hand, implementing a hierarchical FMEA requires that you have proper tools where you're able to trace between several FMEAs. Overall, this can, although this can take a little bit more time to execute, the benefit of this is that one can create a very good and very safe system design.